Hello, my amazing students. This is Mrs. A, and we are going to do 4.1 homework tonight.
Okay, so our instructions on 37 says using probability to form conclusions. In exercises 37 through 40, use the given probability value to determine whether the sample results could easily occur by chance and then form a conclusion. So on number 37, it says, a study addressed the issue of whether pregnant women can correctly predict the gender of their baby. Among 104 pregnant women, 57 correctly predicted the gender of their baby based on data from Are Women Carrying Basketballs by Perry de Pietro Constigan, Birth, Volume 26, Number 3. If pregnant women have no such ability, there is a 0.327 probability of getting such sample results by chance. What do you conclude? Let's recall our empirical rule. We have 68% of all of our data will lie between the 1 and -1 standard deviation, and then 95% of all of our data will lie between 2 and -2 standard deviations. So it's only the part that is considered to the right of 2 or to the left of -2, and there's only 5% of our data that lies over there. Because of this, and we have the high probability of 0.327 or 32%, that they would get those results completely by chance. It shows that the sample results could have indeed easily occurred by chance. It appears that there is not sufficient evidence to conclude that pregnant women can correctly predict the gender of their baby. The probability 33% is just completely too high to appear to be significant. So now we're doing number 35, and 35 tells us to use the 4 children. We're going to use the exercise 33. So let's look up at the instructions here. It says up at the top, probability from a sample space. In exercises 33 through 36, use the given sample space or construct the required sample space to find the indicated probability. So we need to at least read 33 so that we know what we're supposed to do in 35, because they're referring back to 33. So we're going to read 33, which is 3 children. Use this sample space listing the 8 simple events that are possible when a couple has 3 children, as an example 2 on page 138. Boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. Assume that boys and girls are equally likely so that the 8 simple events are equally likely. Find the probability that when a couple has 3 children, there is exactly 1 girl. Okay, so in doing 33, let's go ahead and do 33, because 33 is one that we're going to do shortly anyway. We might as well do that so that we can go understand 35. Okay, so for 33, I just put all of the sample space on the board, and there are 8 options, and basically that is 2 cubed. And we'll learn more about how we come up with this sample space, but there's only 2 options when having a baby. You either have a boy or a girl, and then since there are 3 children occurring in sequence, there are 2 to the 3rd possible outcomes in the sample space. They told us that all of these were equally weighted, and we're trying to find the probability of exactly 1 girl. Well, there were 3 dotted options there that had exactly 1 girl. A girl on the end, a girl in the middle, a girl at the start. And so there are 3 out of 8 is our probability, or 0.375. So that is number 33. And number 35 says 4 children. Exercise 33 lists the sample space for a couple having 3 children. After identifying the sample space for a couple having 4 children, Find the probability of getting 3 girls and 1 boy in any order. So you can see I've made my sample space. Boy, 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 boy. Girl, boy, boy, boy. Okay, so basically you start this by realizing first of all how many you're going to have. I have 2 options and 4 different spaces for children. So 2 to the 4th is 16. I'm going to have 16 different options. So I started with my first column being boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, all the way down. Then my second column, I made boy, boy, girl, girl, boy, boy, girl, girl, boy, boy, girl, girl. And then the third one I did boy, 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 girl, 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 girl. There's 4 of each one. Boy, 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 girl, 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 girl. And then the last one, I do boy, 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 boy 8 times. And then I do girl, 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 girl 8 times. And I have every possible option right there. So what we're trying to get in problem number 35 is 3 girls and 1 boy. Well, it doesn't take you long to figure out that basically you could either have a boy in the last slot, you could have a boy in the second to the last slot, you could have a boy in the second slot, or you could have a boy in the first slot. Those are your 4 options. So we have 16 possible outcomes. We have 4 that give us 3 girls and 1 boy. Therefore, we have 4 over 16, or 1/4. Okay, the next one we're going to do is number 25, and it says find the probability and answer the questions. XSort gender selection. Microsort's XSort gender selection technique was designed to increase the likelihood that a baby will be a girl. At one point, before clinical trials of the XSort gender selection technique were discontinued, 945 births consisted of 879 baby girls and 66 baby boys, based on the data from the Genetics and IVF Institute. Based on these results, what is the probability of a girl born to a couple using Microsort's XSort method? Does it appear that the technique is effective in increasing the likelihood that a baby will be a girl? Okay, so on this problem, number 25, we have 879 girls out of 945 babies born, which means that there is a 93% chance of having a girl if you are using the XSort gender selection technique. Now, that's a pretty high probability of girls. And so the book says, yes, it appears effective. So on this one, when you consider that without any help at all, the likelihood of having a boy and a girl would probably be somewhere close to 50-50. That's a pretty significant amount of probability. So this is the book's answer for that one, number 25. This is the book's answer for that one, number 25. Okay, next we're looking at number 4, and it says subjective probability. Estimate the probability that the next time you turn on a light switch, you discover that the bulb does not work. That the bulb does work. Okay, so on number 4, I'm just going to show you their answer, because the bulb usually works when I turn on my light. It says the answer varies, but the answer would be high, such as 0.999. So maybe that would be saying that 1 out of 1,000 bulbs would not work. So you're usually going to get the light to turn on when you flip the switch. Okay, so now we're doing number 27. Mendelian genetics. When Mendel conducted his famous genetics experiments with peas, one sample of offspring consisted of 428 green peas and 152 yellow peas. Based on those results, estimate the probability of getting an offspring pea that is green. As a result, reasonably close to the expected value of 3/4, as Mendel claimed. Okay, so I prepared this little board when we're talking about green to total. With the probability, we always have the total on the bottom. It's not an odd. Odds would be green to yellow, but we're doing green to total. So we have 428, and then I added together the 428 and the 152 yellows to get 580 total. So 428 divided by 580 turns out to be 74%. We know that 3/4 is 75%. So that's pretty close to what Mendel is predicting. And here is the answer in the book for number 27. Okay, so now we're doing number 19. It says Sydney Smith wrote in On the Conduct of Understanding that it is impossible to fit a square peg in a round hole. So what we're supposed to be doing with these exercises is just expressing this probability in numbers between 0 and 1. And remember that impossible would be a probability of 0. And the answer in the book for number 19 is 0. Okay, so now we're doing number 29, social networking. In a Pew Research Center survey of internet users, 3,732 respondents say that they use social networking sites, and 1,380 respondents say that they do not use social networking sites. What is the probability that a randomly selected person does not use a social networking site? Does that result suggest that it is unlikely for someone to not use social networking sites? So now we look at this and we say, okay, problem number 29, we have 3,732 use social networking, 1,380 do not. The probability of not is the ones that do not, 1,380 over the total. So I had to add the 3,732 and the 1,380 together to get 5,112. When I did that division, I get 0.27. And 0.27 is not unlikely because at least a quarter of the people would be in that zone. So on 27, where's the answer to 27? No, 29. There it is. 29 is what we're doing. In the book it says 0.270. No, it is not unlikely for someone to not use social networking sites because 27% is in that usual range. And we are on our last problem in this section. Kentucky Pick 4. We're doing problem number 41. Okay, it says in exercises 41 through 44, answer the given questions that involve odds. Kentucky Pick 4. In the Kentucky Pick 4 lottery, you can place a straight bet of $1 by selecting the exact order of 4 digits between 0 and 9 inclusive, with repetition allowed. So the probability of winning is 1 out of 10,000. If the same 4 numbers are drawn in the same order, you collect 5,000. So your net profit is 4,999. Find the actual odds against winning, A. B. Find the payoff odds, and C. The website www.kylottery.com indicates odds of 1 to 10,000 for this bet. Is that description accurate? Okay, so let's come back with those answers. All right, so A says find the actual odds against winning. They did tell us that the odds, the probability of winning was 1 out of 10,000. So remember up at the top of the page, this example, it gives you the definition or what to do to find the odds against an event A. Is going to be the probability that A does not happen divided by the probability of A. Or if we have 1 out of 10,000, that means only 1 out of 10,000 would be for you getting the event A, and then 9,999 would be against you. And so we would put the probability of not getting is 9,999, and then the probability of getting event A would be 1. So our odds would be 9,999 to 1, which is what the book gives for answer A also. This is the little section I'm talking about on page 142, and it gives you actual odds against, and it's the probability of A naught divided by probability of A. And then we're going to, in B, we're going to find the payoff odds. So down here in this same box, this is the payoff odds against event A occurring are the ratio of net profit if you win to the amount of the bet. So payoff odds against event A equals net profit to a bet amount of the bet. So in our Kentucky problem, we have the net profit they give us at the bottom of the problem is $4,999, and the amount it costs to bet is just $1. So our payoff odds would be net profit to amount bet, which would be 4,999 to 1. And according to our answer key, that is the correct answer. In part C, we're supposed to be able to find the odds of this bet. And so it seems like they're wanting you to find the odds for winning. Okay, well, at the top in A, we found the actual odds against winning to be 1, 9,999. Remember that over there. 9,999 to 1. So the odds against winning were the 9,999 to 1. So the odds in favor of winning are 1 to 9,999 and not 1 to 10,000, which is the answer. And it is late, and I am going to bed because we are done.
This is Mrs. A, and we have now gone through all of the homework questions on 4.1. I hope this was helpful for you. And I will be back tomorrow with 4.2 and 4.3 to get you ready for your test. Do not forget to do your online homework also. Have a blessed evening.